Hello everybody, welcome to ACE Engineering Academy and ACE online platform. Here we are to discuss the preparation strategy of the electrical power systems. And myself Prasad Meghavarna, and I am doing my PhD in SV University Tirupati, and I am having 12 years of teaching experience only in power systems. So coming to here, power systems, I am saying welcome to the world of power system. In power system, we have to learn how to generate the electrical energy, how to transmit the electrical energy, how to distribute the electrical energy. Which means that the power systems is the life of an electrical engineer. Right? In electrical engineering also, we have to study about the same thing only. We have how to generate the electrical energy, how to transmit the electrical energy, and how to distribute the electrical energy. And coming to the syllabus of power systems, it is the entire syllabus of power system. Here, the generation of electrical energy is there, transmission and distribution of electrical energy, and power system analysis. So you can call it as faults and stability and load flow analysis, and switchgear and protection. So this is the entire syllabus of the power system. So in this, approximately we can expect 13 to 16 marks, right? So in entire power system, we are expecting 13 marks to 16 marks. 16 marks we can expect in entire power system. A minimum of 13 and a maximum of 16 we can expect. Clear? So here today we are going to discuss about the preparation strategy of the faults and stability, which is nothing but the power system analysis. So the power system analysis is completely the analysis part of entire power system, where we are going to discuss about the load flow analysis and the fault analysis and the stability analysis clearly. Now coming to individual weightage of the only power system analysis, clear? So in only power system analysis, in entire power system analysis, we are in entire power systems, we are getting approximately 13 to 16 marks. But whereas in only power system analysis or faults and stability, we are expecting 7 to 8 marks. 7 to 8 marks. A minimum of 7 and a maximum of 8 we can expect. Sometimes it may be 10 also. Right? And in engineering services objective, we can expect a minimum of 4 questions and a maximum of 5 questions. And in conventional, we are expecting up to 50 to 60 marks. So this is the experience of last 20 to 30 years. We are getting continuously this type of marks. Clear, students? And coming to the questions in GATE in the previous years. So we got approximately 2 marks, right? Two 1 mark questions and 2 marks questions in 2018. And 2 1 marks and 3 2 marks questions in only faults and stability, that is power system analysis, and 3 1 marks and 2 marks in 2020. And in 2021 we got 2 1 mark and 4 2 marks questions in 2021. And coming to 2022, so we got 3 1 mark and 2 marks questions. See here, so how much weightage we are having only in the power system analysis or the faults and stability of the power system. Right? Now coming to the engineering services objective. So in 2018 we got 6 questions, and in 2019 we got 4, and 20 we got 3, and 2021 we got 4, and 2022 we got only 3. Right? And coming to the conventional, it is having more weightage in conventional, approximately 40 to 60 marks we are getting. 60, 50, 45, 48 and 48 are the 40 are the marks we got in the recent years. Right? And this is the weightage of only, I am saying it is the weightage of only power system analysis part, right? And this is the syllabus, right, students? So coming to the syllabus of the power system analysis, here first of all we have to discuss about the basics of balanced power system, and in that balanced power system we have to understand so how to analyze a balanced power system, and later on the representation of the power system, entire power system in the per unit form we have to see. So why? Because we are facing some difficulties in the analysis of absolute system in absolute form, so that we are converting our calculations into per unit form. So to reduce the calculation complexity, we are moving into the per unit system. And coming to the matrix representation, the next one. See here, in this, the basics of balanced power system is common for entire, right? So this, with this unit, we have to understand all the remaining units. And whereas second chapter is also common for the remaining all 3, right? So by studying the power system representation in per unit form, so we are going to solve the problems in matrix representation and load flow analysis, fault analysis and stability analysis, right? So that second chapter and first chapter are common for the remaining all chapters. Clear, students? And coming to the matrix representation of power system, basically, so we are having a Z bus representation and Y bus representation, and by using that one we are going to study the load flow analysis actually. But we can analyze the remaining parts also, but in our syllabus or in our power system we are using the bus admittance matrix and bus impedance matrix for analyzing the load flow analysis here. And later on, so in chapter 1 we have seen how to analyze the balanced system, and in chapter 5 we will see how to analyze the unbalanced system. Here we are going to introduce some symmetrical component theory, right? And we will see so how to analyze the power system by using symmetrical components, and how it is going to reduce the complexity of analyzing the unbalanced system, we will see there. And coming to chapter 6, so we have to represent entire power system network in the symmetrical components, so that we are going to draw the symmetrical networks for the entire power system elements. So there may be star connected elements, or there may be delta connected elements, there may be generators, transformers, transmission lines and loads. For all the elements we are going to construct the symmetrical networks. So we are going to represent entire system in the symmetrical network form. And coming to the next one, the most important part is the fault analysis, right? So there we are going to analyze the symmetrical faults and unsymmetrical faults, and finally we are going for the power system stability analysis, right? So this is the overall syllabus of our individual chapter names of the power system analysis. Now coming to the textbooks, so what are the textbooks we can prefer for preparing this power system analysis? So these textbooks are not only preferred for preparing power system analysis, these are also preferred to prepare the entire power system part, right? Entire means major portion of GATE syllabus and major portion of engineering syllabus will be covered in these textbooks. So the first one is power systems, right, by Stevenson and Geiger we can take. So this textbooks is one of the best textbook we can take, right? Power systems by, or power system analysis by Stevenson and Geiger. And coming to power system analysis and design by Duncan Glover. So it is also one of the best book we can say. And later on we are having so electric power systems by John Wheely publications, and one of the best textbook for power systems by Indian professors, great professors D.P. Kothari and I.J. Nagrath, right? So these also one of the best book we can say. So that in all the textbooks the total content is same only, but way of representation of the content is somewhat different. So that take any one textbook, not all the 4, take any one textbook and try to prepare with that. So actually, so whenever you are listening the classes of ACE Engineering Academy, so no need to prepare a textbook separately. So we are going to cover the entire syllabus with neat examples and previous GATE questions and previous engineering services questions, examples discussion, and we are going to give you a very good notes. Clear? And coming to how to practice, that means what to practice to get a very good marks, right? So in the first attempt we have to crack the exam. So to crack that exam in the first attempt, what we have to prepare? So we have to prepare so previous UPSC exam question papers for electrical department. So we are having engineering services examinations and Indian administrative services examination. In those two we are having electrical papers. So take those electrical papers and practice them, right? And up to prelims only, no need of the mains exam question papers. So just practice the prelims exam question papers. And next one, so PSUs you can practice. So we are having a separate PSU exams. So for BARC we are having some good question papers, and DRDO we are having, and ISRO we are having, right? And along with these three, you try to take the SSC JE and RRB JE question papers also, right? So try to practice all these question papers so that you are having more content to prepare and more number of practice questions are there to prepare. And later on, so practice previous gate questions, 1 mark as well as 2 mark questions. So here we are having, so 1 mark questions and 2 mark questions we can take to prepare, right? And later on, so take some state electricity board exams, right? So it may be Transco, it may be Transco, it may be Genco, or any DISCOM, right? Southern Power Distribution or Northern Power Distribution or Eastern Power Distribution or Central Power Distribution. So any DISCOM question papers, right? And sometimes public service question papers also of the state, right? So state PSC, state, so Public Service Commission question papers. So of AEE, right, or EEE, anything we are having in the state government exams. Clear? So we can take different state question papers and we can practice. So whenever you are practicing this set of questions, this is the practice set we have to maintain every time. So previous engineering services and administrative services question papers, and PSC question papers, and GATE question papers, and state government question papers, and SSC JE and RRB JE question papers also. So whenever you are maintaining these, right, so that is a perfect set of preparation, right? So take the syllabus content clearly, and in that syllabus, what are the textbooks we can prefer, right, and what are the question papers we have to download. So these are the things we have to maintain initially whenever we are starting our preparation. So whenever you are getting any doubt about the question, so we have to refer the question textbook or refer the notes given by the faculty, right? So anything we can do, right? And in classrooms, we are going to discuss several number of questions, but still we need more practice set, right? So all the questions it is not possible to discuss in the classroom itself. So we'll discuss more number of questions, but still we need more practice sessions. So for that one, so we have to take all these question papers, right? And the AS Engineering Academy is providing the question papers for almost all these exams we are having. Clear? And coming to the important topics of each chapter, right? So these are the important topics we have to concentrate on each chapter. So actually we have seen the syllabus here. So this is the syllabus, so of entire power system analysis. In this power system analysis, so we'll concentrate on which topics on each chapter, right? Is it required to concentrate on all the topics of the syllabus, or only some portion is sufficient? So we'll see that the important topics that you have to understand. So coming to the basics of balanced power system. So balanced power system in 3 phases, right? Actually before this in transmission and distribution, we are going to discuss about the complex power calculation in single phase system, right? And instantaneous power calculations in single phase system, power transfer equations in single phase system. All those things we should have to understand those. And later on we have to move to the 3-phase system analysis. And in 3-phase system analysis, before entering into the power system analysis, the must and should learn concept is operator J. What is operator J? What is the importance of operator J in our power system? So actually, operator J rotates a vector anti-clockwise by 90 degrees. So whenever you are having any vector, so that vector will be shifted anti-clockwise by 90 degrees. So that should be represented by operator J. So operator J means, so 1 at an angle of 90 degrees. 1 at an angle of 90 degrees. And operator minus J means 1 at an angle of minus 90. Right? So try to understand why, because we are going to use that operator J frequently in our power system while calculating active power and reactive power calculations. Clear? And later on, see the power transfer equations of the single phase system and try to understand and try to analyze them. And from there, so get an idea, so how active power flows in an inductive medium and how reactive power flows in an inductive medium. So by analyzing those equations, we can say that the active power always flows from high value of load angle, that is voltage phase angle, to the low value of voltage phase angle, and in an inductive medium. And the reactive power always flows from high value of voltage magnitude to the low value of voltage magnitude in an inductive medium. Our transmission line is always an inductive medium, so that in inductive medium only we are going to analyze this. So that the operator J will give you the notation of 1 at an angle of 90 degrees, and we have to understand, so whenever we are moving in anti-clockwise direction, the angles will become positive, and whenever we are moving in clockwise direction, the angles will become negative. And from this, the power transfer equations, Please check that active power is proportional to delta 1 minus delta 2, and the reactive power is proportional to sending end voltage minus the receiving end voltage magnitudes. So that the reactive power always flows from high value of voltage to the low value of voltage, and the active power always flows from high value of voltage phase angle to the low value of voltage phase angle, that we can get. And later on we will see the basics of balanced star connected loads, and balanced delta connected loads. In case of balanced star connected and balanced delta connected loads, first of all, try to understand the meaning of balanced system. When we can call a system as a balanced system, and from that one, so get an idea. So when we can call, that is, balanced system means what are the conditions you have to satisfy. So try to understand those conditions. If any one condition is not satisfied in that balanced conditions, we can say the system will be unbalanced. And later on go for complex power calculations in the three-phase system. So whenever the loads are star connected and delta connected. So why? Because we are going to use all those things in the later stage of power system analysis. So this is the initial set, practice set we need, right? And the formulas and the concepts we need to enter into the power system analysis, right? And coming to the next one is the representation of power system in the per unit form, right? So we have to represent the entire power system in the per unit form. Why? Because actually the absolute system is giving us some vast amount of calculations, and we are facing some difficulties in the absolute system, and the magnitudes of the quantities, so voltages in kilovolts, powers in megawatts, and MVA or megavolt ampere reactives, and MVAs, right? So we are having different units for powers and different units for currents, voltages, and resistance, inductance, capacitance, or reactance and capacitive reactance. Several units we are having. So that the calculations are becoming very difficult. To reduce the complexity, we are moving into the per unit system representation. So per unit system is nothing but a simple percentage system. For example, students, suppose if a student is getting actual marks got by the student, suppose if it is 50, suppose if you are choosing the reference quantity or the base quantity, reference quantity of the base quantity or the base marks, we can say the base marks, if it is 100, then what is the percentage value? The percentage value is 50%, and the per unit value is what? 0.5. So that actual value divided by base value, 50 divided by 100, we are going to get 50% or 0.5 per unit. Suppose if you are changing the base by keeping the actual marks, I am getting same 50 marks, and whenever base quantity is changed to 200, then it is not 50%, it will be 25%, right? It will be 25%, and it is 0.25. So that whenever you are changing the base quantity, the actual quantity remains same, but the per unit quantity will be changing. So that based on the reference quantity or the based on the base quantities, the per unit quantities will be changing. Just it is a simple percentage representation or percentages calculation or per unit calculation. And coming to the syllabus, what you have to learn, what you have to understand from the per unit system. First of all, what is the actual problem we are having in the absolute system? That we have to identify, problem identification. So we have to identify what is the problem we are facing in the absolute system. So that we have to represent all the elements of the power system of the single line diagram, so in absolute form. So represent those in the absolute form. So we are having the single line diagram is generator, and we are having transformer, and then we are having the transmission line, and we are having one more transformer, and we are having several loads. One may be the synchronous motor, and one may be the induction motor. So this is the synchronous generator we are having, and then transformer T1 we are having, transmission line we are having, and the transformer T2 we are having, and the synchronous motor and the induction motor. So these are the elements we are having in power system. Represent the electrical equivalent networks of all these elements we have studied in our electrical missions: generator equivalent network, transformer equivalent network, transmission line, and all the remaining elements, electrical equivalent networks. I'll join them, and we are going to get some problem there to analyze those network. It is very difficult to analyze that type of network because of the presence of the transformer. So the presence of the transformer in absolute system is giving you the discontinuity path in the network. Why? Because it is magnetically coupled but electrically disconnected. So that to analyze those type of mutually coupled networks, it is very difficult. So that to avoid that difficulty, we are moving into the per unit system representation. So that in topic 1, we are going to get the problem. What is that? Analyzing that type of network is very difficult. So that we are moving into per unit system. In that topic 2, we are going to see the definition of per unit system. So actual value divided by the base value, right? That is actual value of any quantity in any unit, and take the base value of the same quantity in the same unit, right? And based on that one, so we have to see the per unit system representation in case of the single phase system and in the 3-phase system. So we are having the impedance calculation in per unit form in single phase and 3-phase system, that is single phase quantities and 3-phase quantities. But impedance is always lying in per phase only. The per phase impedance calculation in phase quantities and the line quantities we are going to see in the single phase system and the 3-phase system. And later on we are going to see some problems on those, right? And advantages of the per unit system. So what are the advantages we are having because of the per unit system? It may be the reduction in the calculation, it may be the reduction in the number of equations, or it may be the comparison at 2 different locations, right? And representation of impedance, per unit impedance, or actual impedance of any generator is in per unit form. All those things we are seeing in the advantages part. And the most important point that you have to understand from this one is the construction of per unit impedance diagram. The construction of per unit impedance diagram is very, very important. So it is used for analyzing faults, fault analysis, and constructing symmetrical networks, and stability analysis also. And in sometimes, so for analyzing the load flow analysis also, we need some symmetrical networks. So whenever we are analyzing symmetrical networks, whenever we are drawing symmetrical networks, so that we need the per unit impedance diagram construction or per unit reactance diagram construction, right? The steps involved in the construction of per unit impedance diagram are very, very important. How we are going to construct any network into the per unit form, right? And later on, so we will go for the next chapter, the third most important chapter, students. So in the recent years, for the past 7 to 8 years, last 7 to 8 years, we are having a question in the bus admittance matrix every year. Every year we are having a question in the bus admittance matrix, right? So that first of all we have to see how to construct a bus admittance matrix whenever a network is given, right? So that from this one, so try to understand whenever a power system network is given, how to construct the bus admittance matrix, right? And the equations for the bus admittance matrix and the definition of the Y bus elements. So how they have defined, and from that we can see the properties of the Y bus elements also we have to see. What are the properties? Based on properties also they are having, they are asking problems sometimes. Clear, students? So the definition of Y bus elements, and along with that we have to see the properties of Y bus, properties of bus admittance matrix or Y bus we have to see. Bus admittance matrix or Y bus we have to see, right? Right. And along with that, we have to see the problems on Y bus. Problems on Y bus, we have to see several problems. Whenever a network is given, how to form Y bus, and whenever a Y bus is given, how to construct the network, and several modifications. Right, modifications means sometimes line may be disconnected, sometimes a new line may be added, sometimes we are adding some shunt elements like voltage control devices like shunt capacitor, series capacitor, shunt reactors in the transmission system. So that at that time, what are the changes in the bus admittance matrix, all those things are the most important problems. And later on, bus impedance matrix also we have to see. The bus impedance matrix construction can be done directly in two ways. So one will be by inversing the Y bus. So suppose if it is 2 by 2 matrix or 3 by 3 matrix, so directly we can go so by inverting the bus admittance matrix. But if it is a large size, if it is a 10 bus system or 20 bus system, it is very difficult to go for inversion of Y bus. So that for that bus impedance, we have to go for the Z bus building algorithm. Z bus building algorithm. We are having. So in the Z bus building algorithm, we are having different stages, different steps, modifications. So type 1 modification, type 2 modification, type 3 and type 4, 4 types of modifications we are having. So we have to see that. Clear? So actually, in the recent years, for the past 6 to 7 years, we are not having any question in the bus impedance matrix in GATE, but we are having questions in the engineering services and local state government exams. So that definitely we have to study the bus impedance matrix. If you are exactly preparing for GATE, so you can reduce your concentration in the bus impedance matrix, but you have to concentrate more on the bus admittance matrix. But whenever you are preparing for engineering services or any local state government exams or Indian administrative services, right, or SSCJ or whatever it may be, so you have to prepare the bus admittance matrix also. And you have to see the definitions of the Z bus elements also. So what are the Z bus elements represents and what are Y bus elements represents. Actually, so in our network theory, two-port networks we have studied, the impedance parameters are always called as the open circuit parameters and the admittance parameters are always called as the short circuit parameters. So all Y bus parameters, all admittance parameters we are going to calculate by short circuiting the remaining buses, and whereas the Z bus parameters we are going to calculate by open circuiting the remaining buses. Right? So these are called as open circuit parameters and those are called as the short circuit parameters. Clear? And those are the definitions of what is Y11, what is Y11, what is Z11, right? So like that we have to see the definitions of all the Y bus as well as Z bus elements and different problems on Z bus as well as Y bus we have to see. And without knowing about Y bus or Z bus, we are unable to go for the load flow analysis. The load flow analysis is majorly depending on the bus admittance matrix construction, right? So we have to use in almost all the methods, right? We have to use the bus admittance matrix elements, right? And coming to the next chapter, students, the load flow analysis, the most important chapter of entire power system. The most important chapter of entire power system. So without a question in this chapter, we cannot expect a question paper in GATE or engineering services. So that much most important this chapter is. And so our great professor of India, DP Kothari, says that load flow analysis we can call it as the bread and butter of power system, right? So without this one, we are unable to understand the entire power system. So that is the basic analysis of entire power system, right? We can say it is the heart of power system, it is the brain of power system, it is everything of power system. So without knowing about the load flow analysis, right? So we are unable to calculate we are unable to go for the remaining analysis. What are those? Load flow analysis and stability analysis. It is the first analysis we have to do. The first analysis that we are going to perform on the power system is the load flow analysis. That's why the great professor, so DP Kothari, says that it is the bread and butter of power system, right? So that the first topic that you have to learn here it is, what are the static load flow equations? So what are the load flow equations? So where we have to start, from where I have to start my analysis. And from the load flow equations, so we are going to classify the buses based on the load flow equations. So those load flow equations are giving some functions and variables, and we are having two functions with two variables. Those functions are active power and reactive power, and the variables are the load angle, that is voltage phase angle delta and voltage magnitude voltage V, right. So based on that one, we are going to classify the buses, right, as PV bus and PQ bus and slack bus, right. They are the different types of buses classification we are having, and that is one of the most important part, classification of buses. And later on we will go for the iterative methods. So all these methods are the iterative methods we are having, iterative methods, right. So the iterative methods, Gauss method and a small implementation of Gauss method, Gauss-Seidel method, and later on a separate logic, one of the best method we can say the Newton-Raphson method, some approximations from Newton-Raphson method, decoupled, some more approximations, so from decoupled method, fast decoupled method, and the comparison between all the methods you have to see. And in all these three, Gauss-Seidel method and Newton-Raphson load flow method are the most important methods. In Newton-Raphson load flow method, so the most important concept is so the Jacobian matrix construction, right. So the finding the size of Jacobian, and in that individual size also they are asking, right. So Jacobian size, I told you already, the load flow analysis is the first analysis that you have to done on power system. From the load flow analysis data only we are going to get the pre-fault voltages in load flow analysis, right, and initial loading condition in the stability analysis. So while calculating the fault currents in fault analysis, we need the pre-fault voltages that will be given by the load flow analysis. And for analyzing the equal area criterion, right, for analyzing the stability of the system, we need the initial operating loading condition of the power system that will be given by the load flow analysis. Clear? So without understanding this load flow analysis, we are unable to understand the remaining parts also. We are unable to calculate it. Clear everybody? Right. So this is chapter 4. And coming to the next one, the chapter 5. Right. So now here comes the unbalanced system analysis. So up to now, so chapter 1, chapter 2, chapter 3, chapter 4, just we are seeing the balanced system analysis and steady state operation of the system. The load flow analysis we are doing under steady state operation only, by assuming that there are no faults in the system. But coming to the next one, we have to analyze the unbalanced system. In chapter 1 we have seen the balanced system analysis, balanced star loads and balanced delta loads, and I have seen some conditions there, and one of those conditions will be unsatisfied, so that the system will become unbalanced power system. So that we will see what are the difference between balanced system and the unbalanced system. What are the conditions? So how to represent a unbalanced system? So that how can we identify that system is unbalanced, right? So that's why we have to see the basic difference between the balanced system and the unbalanced system. And later on we have to go for the symmetrical component theory, right? So the symmetrical component theory is given by C.L. Fortescue, the great scientist, who has introduced the symmetrical component theory. So according to him, any unbalanced system can be resolved into set of balanced systems, like a Fourier series. Any non-sinusoidal signal can be represented as a set of sinusoidal signals. Like that, similarly, any unbalanced system can be resolved into set of balanced systems, that is positive sequence system, negative sequence system, and the zero sequence system we are going to represent. And we will take a simple system, a simple generator, and we will take the voltage equations of that generator, and we will try to implement those equations in the symmetrical components, positive sequence, negative sequence, and zero sequence. Similarly, we will take current equations and we will try to implement them in the symmetrical components, and we will analyze those equations, voltage equations and current equations, and we will calculate the complex power in the symmetrical components, right? And we will represent entire power system in the symmetrical component form, and we will see how to analyze the unbalanced system. The steps, what are the steps involved in analyzing the unbalanced system, right? These steps will give you, for analyzing an unbalanced system, it is better to go with symmetrical components. Why? Because absolute system or actual system will give you the problems, so that definitely go with the symmetrical component theory. And in that symmetrical component theory, construct the networks for the entire power unbalanced system. So networks means we are having several machines, elements, generators, transformers, transmission lines and the loads. For those elements, represent those networks also in the symmetrical network form. That means construct the positive sequence networks of those elements, negative sequence networks of those elements, and zero sequence networks of those elements, and later on interconnect them. If it is positive sequence network, so draw positive sequence networks of all elements. What are those? Generator, transformer, transmission line and the loads. Take positive sequence network and interconnect them and analyze them. If it is negative sequence, so interconnect them, analyze them. If it is zero sequence, draw the zero sequence network of all elements, interconnect them and analyze them. If the fault requires all the three, positive sequence, negative sequence and zero sequence, you have already taken positive sequence separately, negative sequence separately, zero sequence separately, so take them and analyze. So that analysis is very simple compared to that of the actual system of analysis. So without symmetrical components, the analysis of unbalanced system is very, very difficult. That is why we are going with the symmetrical component theory. Understand, students? The symmetrical component theory is simple mathematical tool to analyze the unbalanced systems. Clear? And later on there are some proofs. The same symmetrical component theory can be used to analyze the balanced systems also. It is not at all having any problem. It is giving only positive sequence components whenever the system phase sequence is positive. Clear? So based on that one, so we are having some very good conclusions from this chapter. So try to understand this chapter. So without understanding this chapter, we are not going for, we are unable to analyze the faults of the system. Clear? So that in this complete chapter, so you have to concentrate on symmetrical component theory and this one. And whereas in the previous chapter, you have to concentrate on classification of buses and the Gauss-Seidel method and Newton-Raphson method. And here you have to concentrate more on the problems of the Y bus and elements here and the bus admittance matrix constant. If it is only gate, and if it is the other exam, you have to concentrate equally on all the remain also, right? And coming to students, the next chapter, see here, already we have seen the steps to analyze unbalanced system. In that, we have seen construct the networks, positive sequence, negative sequence and zero sequence networks of all elements. That is the major important step we have studied in chapter 5. So how to construct? This is the chapter. So we have separated this chapter as a separate construction of networks of all the elements, right? So that here we have to see symmetrical network construction of star connected networks, delta connected networks, synchronous generator, transformer, transmission lines, and symmetrical networks of synchronous motor and the induction motor, and finally the problems on the networks. So here your concentration should be more on symmetrical network construction of star connected networks, majorly we are having that, and symmetrical networks of the generator, star connected and delta connected generator, and symmetrical networks of transformer and the transmission line, and the how to draw the networks of the combination of all. So these are the major important topics that you have to concentrate. So symmetrical networks of star connected, symmetrical networks of transformer, generator and transmission line, and the problems we have to concentrate more if it is gate. If it is not GATE, if it is engineering services or any local state government exam, so you have to give your concentration for almost all the topics. Why? Because so in local state government exams or engineering services, they are going to ask the theory questions. The theory questions they may ask at any part. Clear? And mathematical questions formation will be high priority. That means most possible only in these concepts. Clear? And without this chapter, so we are unable to analyze the fault analysis. So for fault analysis, we need chapter 5, chapter 6, chapter 5 and chapter 6 and chapter 2. So per unit system representation and symmetrical component theory, symmetrical networks. Chapter 2, chapter 5 and chapter 6 combinedly will give you the fault analysis. Clear? And coming to the fault analysis, so the most important concept, right? So without expecting a question in fault analysis or load flow analysis, right? We cannot expect a question paper. Every year we are having a question in the fault analysis. That may be in LG fault, or that may be in LL fault, or that may be in LLG fault, or that may be in the symmetrical fault. Clear? So first of all, we'll start with what are the types of the faults? What are the types of the faults we are having in the power system? The types of the faults we are having in the power system are maybe open circuit faults and the short circuit faults, or series faults or the shunt faults. Series faults are open circuit faults, shunt faults are nothing but the short circuit faults. So based on that one, so we will analyze what are the consequences of open circuits. When open circuit occurs, what is happening in the power system, and what are the consequences of short circuit faults. So that how to analyze, how to understand whether there is a short circuit fault or open circuit fault. Based on the consequence also we can understand whether there is open circuit fault or the short circuit fault in the power system, right? And what are the causes? What are the causes of open circuits and what are the causes of the short circuits we have to see in this fault analysis. And later on we have to see, that means our concentration in the syllabus, it may be engineering services or local state government exam or GATE, our concentration is majorly on the short circuit faults, right? So that we are going to see the types of the short circuit faults in the system. So the types of the short circuit faults are nothing but symmetrical faults and unsymmetrical faults, right? So symmetrical fault analysis first of all, so without using symmetrical component theory, right? The symmetrical fault analysis on unloaded transmission line and unloaded synchronous generator we will see. We will analyze them and we will get some very, very important conclusions, and it is one of the most important concept you have to understand here, right, in this one. And remaining all, thus unsymmetrical fault analysis, these are the unsymmetrical faults, or unbalanced faults, right? Symmetrical fault is a balanced fault and unsymmetrical fault are nothing but unbalanced faults. So here we are having line to ground fault, line to line fault and line to ground fault analysis. Clear everybody? So they may be asking a question in LG fault, or they may be asking a question in LL fault, or they may be asking a question in the LLG faults. So in different exams, right, they are asking questions in the different faults. So the probability of, or the choice of making questions in this chapter is very high. So that the probability of getting questions in the exams is also very high. So that you have to concentrate more on the fault analysis of the system. But remember students, to understand the fault analysis, we have to definitely study chapter 5 and chapter 6 and chapter 2. Clear? So directly they will give some network, and the network we are having the fault, so that the system will become unbalanced. So that you have to understand, so how to analyze the unbalanced system, how to draw the networks of that one, and what is the type of the fault. Based on the type of fault, we have to calculate. They may be asking the positive sequence currents, negative sequence currents, or zero sequence currents, or the fault currents, or the fault impedances, or the sequence network, right? Circuit breaker ratings, or the short circuit capacity of the bus, right? So one of the most important concepts you have to learn for all these concepts, what are those? Symmetrical or unsymmetrical faults. So majorly they are asking the short circuit capacity or the fault level, and circuit breaker rating. So these are the two important things we need, right? First, basically, why we are going for fault analysis? Why we are going for fault analysis? We are going for fault analysis to identify the circuit breaker rating and to identify the relay setting. So at which condition the relay has to operate, and for which condition or what is the rating of the circuit breaker we have to identify. So to do that we are going for the fault analysis. Clear? So remember, so the fault analysis is done. The fault analysis is done to identify the current setting of the relay and to identify the circuit breaker rating. Clear? That will be given by the fault analysis. So one of the most important chapter. Clear? And finally, see the symmetrical fault analysis also with symmetrical components, by using the symmetrical components also. So it is also the most important. So all these, so what are those symmetrical fault analysis without symmetrical components, and LG fault, LL fault and LLG fault, and the symmetrical. In symmetrical faults we are having what are those? Triple L and triple LG. Triple L and triple LG faults we are having. So these are the two types of faults we are having. And LG, LL, LLG, triple L and triple LG, all these faults you have to concentrate equally. So they may be asking question one year in LG, next year in LL, next year in LLG, like that they are asking the question, students. So be prepared, and this is the one of the most important chapter of fault analysis, power system analysis. And coming to the power system stability analysis, the most important, right? So here also the probability of asking the questions every year they are asking the questions, right? So in this one, first of all, understand the definition of stability. So bounded input and bounded output stability, what is the meaning of that stability, and what are the types of stabilities, right? So what are the problems we are going to get? It may be voltage stability, or it may be frequency stability, or it may be rotor angle stability. So in our power system, we are studying only about the rotor angle stability. Rotor angle stability. So we are not studying about the voltage stability or the frequency stability of the system. So here in our power system syllabus, it may be any exam, engineering service or GATE or any local government exams. So we are concentrating only on the rotor angle stability. And what are the ways, what are the different analysis parts we are having in that? We'll see the steady state stability analysis and the transient stability analysis, right? So steady state stability analysis and the transient stability analysis, both are very, very important. Steady state stability analysis and transient stability analysis, both are equally important. Clear? And the steady state stability analysis we are doing, only by using the power transfer equations, and whereas the transient stability analysis we are unable to use that power transfer equations directly. Why? Because the fault will be very large. So because of huge faults, so we are going to derive the swing equation. The dynamic model of the rotor should be studied. So whenever you are studying the dynamic model of the rotor, we are able to analyze the transient stability of the power system network. And later on we have to study about the inertia constant and the problems on, so inertia constant and angular momentum and inertia and apparent power, yes, apparent power rating, yes. So all these are also very, very important. And the most important concept of power system stability analysis, the equal area criteria, right? And sometimes they are asking here also, sometimes they are asking the transient stability and the steady state stability. So these are the highly concentrated areas and most important areas in the power system stability analysis. And so to study this power system stability analysis, we need the second chapter and first chapter very clearly. Clear? So first chapter is the basics of balanced system, and second chapter is the basics of per unit system representation. Clear, students? Now, so coming to all these chapters here, in all the chapters, we can expect at least one 1 mark or one 2 mark question, right? So one 1 mark or one 2 mark question we can get in the chapter 1, so that we can get 1 mark or 2 mark. 1 mark or 2 mark. And in chapter 2 directly they are not asking questions directly in chapter 2, but without chapter 2 we are unable to go for this one. Sometimes they may ask, so 1 mark directly in the per unit system. And coming to the matrix representation, we can definitely get 1 mark and 1 2 mark. Majorly we are getting so 2 marks questions or 1 mark questions, right? Sometimes. So that we can definitely expect 1 mark or 1 2 mark question here also. And in load flow analysis also we can expect so 1 mark or 1 2 mark question. So 1 mark or 2 mark question we are expecting. And in chapter 5 no direct questions we are having in chapter 5. So maybe we can expect only 1 mark. Alright. And in symmetrical networks we can expect 1 mark or 1 2 mark question or 1 2 mark question. And load flow also, so 1 mark or 1 2 mark question we can expect. And here also 1 mark or 1 2 mark question we can expect. That means the meaning of that one is we can definitely expect a question in these two, right? And here also in these three we can definitely expect a question. And along with that, nowadays in the last 4 to 5 years every year they are asking in the question in the balanced system analysis also, right? In symmetrical networks sometimes they are asking, right? For every 2 to 3 years continuously they are asking the questions, right? And matrix representation also one of the most important part. Clear, students? And the remaining chapters are the basics of those chapters. So hello everybody. So this is the preparation strategy for the power system analysis, and prepare well and concentrate on these topics, right?